Welcome learners for the lecture third of a differential geometry. Today we are discussing about the nature of the surface. How to do considering in the natural form will be uses in this condition. Okay. First and second lecture we discussing about the first is generated as a content and the definition of the surface. Second is some example will be given in the form and third will be generated to the form. Okay, nature of the points on the surface. Then let us go start it. Some nature that will be generated. Let r equals to xyz be the position vectors on the surface. Since xyz are the continuous function of the parameter u and v possessing partial derivative of the required order, we take to the form that is a r equals to uv as a parametric equation of to the surface. If we use it as a suffix 1 and 2 are used to the partial derivative of r with respect to u and v, r1 r2 generated to the form of the Jacobian form will be generated. Okay, let us go started. That is a let r1 equals to delta r upon delta u and r2 equals to delta r upon delta v. Okay, this is the first equation. Second equation will be generated. R11 equals to del square r upon del u square. R12 equals to del square r upon del u del v. R21 equals to del square r upon del u del v, and R22 equals to del square r upon del v square. Okay, they will both of this condition will be generated. Since to the representation of the suffix notation will be generated, that is the partial derivative. What is meant by suffix? Suffix means these 1 2 position will be generated to the any notation is considering to the lower part will be generated. Okay, r12 equals to r21 will be representation of this form. Okay, same as a condition will be generated to the form. Since r equals to xyz can be expressed as r1 and r2, both of this representation of the form. R1 equals to del x upon del u, del y upon del u, and del z equals to del z upon del u. X1, Y1 and Z1 representation. Same as R2 will be represented to the form. Del x v notation will be generated to the form. Okay. X2, Y2 and Z2. Sorry, mistake. They considering as a X2, Y2 and Z2. Both of these represent. And similarly, some expression will be used as a R22, R11, R12 and R21 in this form. Okay. Definition will be generated to the form that is a what is meant by singularity. If R1 considering as a R2 is not equals to 0 at a point on the surface, then point is called as an ordinary point, and a point which is not as an ordinary point is called as a singularity. What is meant to the form? R1 into R2 is not equals to 0 means R1 into R2 does not contain as a 0. This point is called as a ordinary point. Means suppose that we given as a form, suppose that R1 is generated as a 1 and R2 is considering as a 2. 1 into 2 equals to considering as a 2 is not equals to 0. This point is called as a ordinary point, and this a point which is not an ordinary points means equals to 0 means R1 is generated as a 0 into 2. They considering as a 0, hence is not equals to 0, considering this equation is called as a singularity. Okay, this is the difference between ordinary point and singularity. What mean form? R1 into R2 is not equals to 0 means to the form R1 into R2 they considering as a not 0 than a other value. This is called as ordinary point, and if we considering as a they value is a 0, this is called as the singularity. Okay, this is the definition. Important definition, concept clearing definition will be generated ordinary point as well as a singularity form. Okay, from very definition of the ordinary point we use it to the form that is the using R1 into R2 equals to I Y1 Z2. I considering to the value Y1 Z2 minus Z1 Y2 plus J considering as a form Z1 X2 minus X2 Z2 plus K considering X1 Y2 minus Y1 X2. You know that this representation will be generated same as a matrix form. If we generated as a I value, first row will be neglecting to the form, only as a second and third row will be considering multiply both the cross multiplication. Okay, this will be the concept is generated. This is a third equation. then R1 into R2 is not equals to 0. This means that the coefficient in equation 3 is different from a 0. Hence, it is called as at least one member of this form that will be generated to the equation y1 z2 minus z1 y2 will be considering both of these separating form will be generated is not equals to 0. Then matrix form will be generated. M, since least one of this member of a equation 4 is different from a 0, this is called as a ordinary point. This is not a singular point because they does not consider as a equals to value 0. There exists at least one determinant of the minor of this form, that is the 2 of a, in other word, the rank of a m is a 2 of the ordinary point. Consequences, if the rank of the m is either 0 or 1, the point on the surface is a singular point. If given as a 0, it will be considered as a singular point. It's a non-zero, they consider as a ordinary point. Okay, third point will be represent if R1 into R2 is not equals to 0 or equivalently if their rank of the matrix is 2, then xyz is uniquely determined to the parameter uv to considering as a ordinary point. Since the matrix M of a rank 2, there exists at least one non-vanishing to the value. Jacobian form is also considering to the value that will be the delta xy upon delta uv is not equals to 0 to the form will be generated. Same condition considering as a inversion theorem. You know that inversion theorem we considering as a BSc second year. Okay, this inversion theorem is satisfied to the value that will be generated to the form for the every value of the xy is an elements of a n, x0 y0 will be considering to the form. Same as a uv condition will be generated, u generated uxy and v generated vxy. Hence uv are the determinant by a xyz to considering as a ordinary point. The points where the rank of a m is a 1 or 0, the singular point. Now considering as to the form, if 2 generated to the value is directly represented as a it is a ordinary point. The points where rank is generating to the form is if the rank of a matrix M is a 1, then every determinant of the minor order to generating as a M is a 0. We generate it as a considering to the form. This implies y1, z2, z1, y2, all this form are all 0 so that r1 into r2 equals to 0. They show to the inversion theorem. Okay, hence the points where the rank of a M is 1 to the singular form. If we given to the form 0 or 1 value for the singularity, they generated as the rank is a 0. Hence rank is a 0, they considering as a singular points. Okay, when the rank is m is 0, then all determinants of the minors of order 1 or 2 are 0. Hence implies to the from in the previous case we generated r1 into r2 for equals to 0, the set to the rank m is a 0. This is called as a singular form. Otherwise we given to the rank will be generated as a 2 3 4 5. This is considering as a ordinary form. Okay, this will be generated.